Hello. Okay, in this video we're going to be looking at reciprocal identities, Pythagorean identities, and tangent and cotangent identities. So first we'll have a look at the reciprocal identities, and we'll introduce some perhaps new trig functions that you may not be aware of, and we'll just get them right. We have the cosecant or cosec of theta would be 1 over the sine of theta. The secant of theta would be the secant 1 over the cosine of theta. And the cotangent is equal to 1 over the tangent of theta. So expressing these in terms of the ones that we already know, sine, cos and tan, sine theta equals 1 over cosec theta, cos theta equals 1 over secant theta or sec, and tan theta equals 1 over cotangent theta. Now we come to the Pythagorean identities. Sine squared theta plus cos squared theta equals 1. Tan squared theta plus 1 equals sec squared theta. And 1 plus cotangent theta equals cotangent squared theta equals cosecant squared theta. Okay. And just to finish off the identities and the sort of theory aspect of this, tan theta equals sine theta over cosine theta, cotangent theta equals obviously the inverse or the reciprocal of that, cos theta over sine theta. Note that sine squared theta means sine theta times sine theta. Sine squared theta means sine theta times sine theta. Now, what I wanted to have a look at now is these Pythagorean identities. So we start with our right angle triangle, and hypotenuse of course being the longest side opposite the right angle. We've got our angle theta here, and the side opposite that, O for opposite and A for adjacent. So we know that the opposite side is h, the hypotenuse, times sine theta. The adjacent side is h times cosine theta. Now by Pythagoras theorem, or our theorem of Pythagoras, h squared, the square on the hypotenuse, is equal to the sum of the squares of the other two sides. In other words, the opposite side squared plus the adjacent side squared. So we can say that h squared equals, now we know here the opposite side is equal to h sine theta, so h sine theta there, all squared, and the adjacent side is equal to h cos theta, so h cos theta all squared, just substituting into this here. And just multiplying that out, h squared equals h squared plus sine squared theta plus h squared plus cosine squared theta. We can see that h squared is a common factor of all three of those. So we divide through by h squared. That'll keep the equality or the equation the same. So h squared over h squared is 1. Sine squared theta, the h squared over h squared becomes 1, sine squared theta, h squared over h squared here becomes 1, cos squared theta. And there we have our identity there. 1 equals sine squared theta plus cosine squared theta. Now, let's have a look at the next identity here. And what we do here is just divide through everything by cosine squared theta. Now, this is just to do this next one down here. So 1 over cosine squared theta will be sec squared theta, just using our identities from further up here, using our identities from here. Sine squared theta over cosine squared theta will be tan squared theta, and cosine squared theta over cosine squared theta will be 1. So there we are, we've derived our second identity. Now I've put these little arrows here to indicate that we are using this here, and we're just going to divide through by sine squared theta. Here we divided through by cos squared theta. So 1 over sine squared theta is cosecant squared theta equals, and there we have sine squared theta over sine squared theta equals 1, and cos squared theta over sine squared theta would be cotangent theta. So there we are, we have derived all of the identities there on the page using these various aspects of them. So, that's all very well and good. So let's see what we can perhaps do with this. We'll turn off that layer there, and we'll turn on this next one. So here we are, solving the equation 4 minus 4 cos x equals sine squared x. For the domain, now the domain is the range of the x values, or the domain is the extent of the x values. So we want to go from minus pi, which in radians that's 180 degrees, so from negative 180 degrees through to plus 180 degrees. Okay, so from negative pi from x through to there, like that. Remember, the domain is the extent of the x values, the range is the extent of the y values. Okay, so we have here our little trig identity here. Sine squared x equals 1 minus cosine squared x. We can just get that from this one here by rearranging that. So we write down our equation here, but we substitute for sine squared x, we substitute 1 minus cosine squared x. So we can see there that it's everything, our variable, if you like, cosine x is constant. We have all one variable. So if we collect all our terms, take them over to the other side, we get 4 minus cosine x. This 1 comes over to be minus 1. The minus cosine squared x becomes plus cosine squared x, and that's all equal to 0. Collecting our terms and putting them in order, cosine squared x minus 4 cos x plus 3, which is the 4 minus 1, equals 0. Now, just to make things a little easier, we let u equal cosine x. It just gives us, then we can write the formula in a familiar quadratic formula that we should be familiar with. U squared minus 4u plus 3 equals 0. Putting our brackets out, we can see that that would be u minus 3, u minus 3. The plus here indicating that the signs are both the same. The negative here indicating that they're both negative, and that the factors, the only factors of 3 are 1 and 3, would add together or be 4. So then we can draw the conclusion from that cosine x equals 3 or 1. Now 3 is outside of the range for the cosine function. The cosine function only ranges between 0 and between negative 1 and positive 1. So that means that only cosine x equals 1, and therefore the reciprocal, or the cos to the negative 1 of 1 is 0. So when x is 0, cosine of x would be 1. So there we are. That's that one done and dusted. Relatively simple, really. So let's have a look at another one now. It's this one here. Solve the equation tan squared x plus sec squared x minus 2 sec x equals 11 for the domain 0 to 2 pi. 2 pi is 360 degrees. In this, we're going to use the identity tan squared theta equals sec squared theta minus 1, which is from over here. We're going to be substituting into the equation for tan squared x. So for tan squared x, we're going to put sec x squared, sec squared x minus 1, and then the rest of the equation, plus sec squared x minus 2 sec x minus 11 equals 0. Collecting our terms together, I've brought the 11 over from the other side, net minus 11, what you do to one side you must do to the other. 2 sec squared x minus 2 sec x minus 12 equals 0. Clearly we can see 2 is a common factor, so we can divide everything by 2. Sec squared x minus sec x minus 6 equals 0. Now we let u equal sec x, just to make things a little easier when we factorize our quadratic. So u squared minus u minus 6 equals 0. We put in our brackets, our u in here. We know our factors of 6 are 1, 2, 3 and 6. We are looking for two numbers. The negative here tells us that the numbers will have different signs. The negative here tells us that the largest of the numbers will be negative and that the difference between the numbers will be 1. For the 1 that you could imagine being there, but we don't need to put it there because it's 1. And so we get u minus 3, u plus 2 equals 0. Clearly sec x equals 3 or negative 2. If that's 3, that'll be 0. If that's negative 2. Now cosine x equals 1 over sec x, so cosine x would equal 1/3 or negative a half, 1 over 3, 1 over negative 2. This is on the basis of these reciprocal type things here. That's 1/3 and a half is very good because that is the range of the cosine function being -1 to +1. So straight away we can now go x cos to the -1 1/3 is equal to 70 degrees 31/44. But because our domain is 0 to 360 degrees, we must consider all the quadrants. We know, and we have this little thing, or mnemonic, which tells us which functions are positive in the various quadrants. Noting, of course, here that our degrees in maths go from 0 here through 90, 180, 270, 360, which is somewhat different to what we do with bearings and surveying. So we use our mnemonic, all survey tutors count. Now that means all positive here, just the sine positive here, tan positive here, and the cosine positive here. So we can see that we have positive cosine here, which is the one we've got, and another one here, and we take the angle 70, 31 minutes 44 seconds away from 360 degrees, and that will give us 289, 28 degrees 16. So we have two solutions there. X equals cos to the -1 negative a half gives us a solution of 120 degrees. We know that cosine is 0 in there. There's also another cosine is negative in this one here, also in this one here, so we take the same angle, which is just 30 degrees before here, which is 270 minus 30, which would be 240 degrees, and again that gives us the two solutions. And there you are, Pythagorean identities and reciprocal identities and tangent and cosine identities. We've done it, and we've used it in a couple of examples to show how they can be used in a mathematical context.